You have told me that this congruence stuff is a revision for you, yet when I offered that you could just take the test so we could get out of the way, no one called my bluff. So I told you that I'll always teach you from scratch because I don't like it when people say, oh, you should have just known that. That's not how I operate. I'll teach you from scratch, except for one little aspect here, which is just assume knowledge, but you'll be able to chuck it into your cheat sheet. You'll see when I get to it. So, let's review what congruence means. Two figures are congruent if they are the exact same shape. What does that mean in maths terms? All the angles are the same. And that they are the same size. What does that mean in maths terms? All the side lengths are the same. Now, triangles. What is a triangle? What is the definition of a triangle? They've got three sides. They have three angles. And does anyone know what the sum of the angles in a triangle is? 180 degrees. Why is that useful? Because these properties mean we have four specific ways to prove that two triangles are congruent. You told me you've done this before, so tell me, what is this diagram showing? Yes?
All the sides are the same way.
Good. So what did you call that in previous years?
SSS.
Good. SSS. What do you reckon SSS stands for? Good. Side, side, side. All sides same length. Please be aware, it doesn't matter what the diagram is drawn to be, it matters what the labeling indicates. Because this, does that look like a square, what I just drew there? A square. What is the definition of a square? 90 degrees, all sides the same? Is that what I've drawn there?
No.
No? So that is not a square. But if I drew this, have I indicated that all the corners are right angles?
Yeah.
Have I indicated all the sides are the same?
Yeah.
That's a square, okay? So I'm not going to draw these diagrams perfectly with a ruler. You have to follow what the symbols say. So if the line, what do these single dashes mean?
The same length.
That those are the same length, the double dash is the same length on both, etc. What is this diagram indicating? SAS, side, well, good, angle, side, but there's something else to it. Yes?
The angle has to be in between the two.
Good.
sides.
Do you know what the term is for that angle that's between the two sides? It starts with an I. No? Isosceles means a triangle that's got two. That's fine. We're sorting that out now. So, two sides and the included angle are the same. The included angle is the angle between the two lines that you know. Very specific. Because if I did this, copy this down properly, but if I did this, that's not side angle side anymore. Because that angle's not between those two sides that I know. So, SAS, yes, that's good. But if you just took that as given, all you might look for is a side, and an angle, and a side. The position of that angle is very important. So this is stuff that will go on your cheat sheet for this. Your cheat sheet can be very short this time, except for filling it up with examples. Does anyone remember what this one was? Or you could tell it from the diagram. What do I know about? Good, and? Side, but there's some. So last year, you probably would have called it AS, maybe? Yes?
Angle corresponding.
Yes, so you remembered. There's more to it, just like this. It should be a car S. Because what do you notice about the side that you know? Is it adjacent to A? Is it touching A? Because if the known side was here, this wouldn't work. So a car S, which is angle corresponding, space, corresponding side. What does that mean? Two sides known and angle in same place, that makes it congruent. This last one, does anyone remember what the code was for it? RHS. Well done. What do you reckon RHS stands for? So you check, is it a right angle triangle? Right angle, hypotenuse, and a side. That's self-explanatory, it's in the name. Can you please get, that should go on your cheat sheet unless you remember it. I trust you to remember it, but other people, up to you. You've got space. You get a one-sided A4 handwritten note sheet again. This is my personal, when we get to this is my personal favourite topic in maths. You feel like a little lawyer, like a little arguments. The topic we're doing, geometric reasoning. Okay? The last thing we were doing was called trigonometry, SOHCAHTOA. What we're doing now is called geometric reasoning. Alright, I'm going to move this over to the left. I want to be able to show something on the screen. Alright, I'm hoping, and it seems like whoever you've had for maths has done their job, okay? Because you remember this stuff. You just haven't had it my particular way. I'm hoping that you did proofs like this. What is a proof using congruence? Because we have 4 facts here that prove that 2 triangles are congruent. These are useful because they can be used as part of a 2-column proof. Is that actually on the camera? I moved it too far. Is it in now? Those 4 ways can be used as part of a 2-column proof used for solving problems. In maths, what is a 2-column proof? It's an accepted method of posing an argument, a proof. It can be in the form of a table with 2 columns. But what is required is, I don't need you to write it as a table, but what is non-negotiable is there's multiple lines in this proof. Each line has 2 parts, a statement followed by a reason. The statements are facts that support your argument. The reasons are geometric reasoning facts, which you'll see attached to DayMap, once I've given you time to copy this down. And then the final line is a statement that answers the question you've been given. Also, in this argument, in this 2-column proof, you're going to be using these symbols. Can anyone tell me what the triangle of dots means? Pointing up. Well done. What is it when it's pointing down? Because, well done. These ones you wouldn't know. If you had 2 lines poking up like that, that means parallel, so you don't have to write, you can parallel. If you draw a triangle, it's a triangle. If you have this, you'll see in your book that they also have this little angle above things. You can use that for angle as well, but I like to write angle symbol as like a wonky L. Okay? And congruent is an equal sign. Does anyone know what that symbol is? It's to the left of the number 1 key on your laptop. It starts with a T. This is called a tilde, okay? But an equal sign with a tilde on top means congruent in maths, okay? So here you get this explanation for what a 2-column proof is, and then I'm going to show you the geometric reasoning facts, which is the closest thing to not personally teaching you that I'll get to, because it'll... That little picture on the right of the screen, have you seen stuff like that before?
Yeah.
I'll move this off to the side. Don't copy this down. But you might need it on your cheat sheet for when you're going to get assessed. This will be the closest thing to me not teaching it to you from scratch. Why? Because I can just teach it to you by pointing there. If I've got a bunch of lines meeting at a central point, all of those angles formed there, what are they going to add up to? 360, because what is the angle that I've turned if I turn around in a circle? 360 degrees. If I'm facing here, and then I'm facing there, what angle have I turned? On a straight line, 180 degrees. So the angles on a straight line will add up to 180 degrees. If you have two straight lines, the angles opposite each other, they're equal. What's the fact called? Vertically opposite. This is what you should have done in like year 9, I believe. But if you've got, what do those arrows mean? Do you remember? That means that those lines are never going to touch, ever. They're the same distance apart the whole time. They're parallel. If you have a line going through those two parallel lines, these angles are corresponding. This is important because this is the argument. If you use the wrong argument for it, your proof falls over. Okay? More. Parallel lines, a line going through it, these angles are equal as well. That's called alternate angles. These two here, still parallel line, but these angles here add up to 180. Why? Well, I can prove that to you because according to the rule before, according to this rule here, what do I know about this angle?
The same as the one on the other side.
Yeah, it's A. And if I know that that's A and that's B, what angle is on a straight line? 180. Can you see how they get to that proof without showing that? Angles of a triangle, you already told me, are 180 degrees. Exterior angle of a triangle. If I have a triangle and then extend the line across, these two angles add up to this external one here. And then you said isosceles. What's special about an isosceles triangle? Two sides are the same. If I know that a triangle is isosceles, if I draw a vertical line there, it's going to make two right angle triangles. Don't copy these down, just have it open on your day note. But when you're revising, when you're writing your cheat sheet, any of these that you don't remember, you add it. I don't know what you don't remember. That's up to you to decide. Equal angles of a triangle. If you know that the two base angles are the same, it's isosceles. What are the angles of a quadrilateral add up to? 360. Okay. Can we see? Let's see. This is my favorite part of this topic, is doing the proofs. In the figure below, show that AB is parallel to DE using congruent triangles. And I'm going to use this 2-column proof thing. So, multiple lines. And in those lines, what are the two bits? statement and a reason. What are the reasons? These things. And what am I using to pose my argument? I'm using these little symbols here. Okay. I need to use congruent triangles. So I need to prove that these triangles are exactly the same. Which of those four congruent triangles options you reckon I'll be using? Well, I just need to use one of them. Any idea? Yeah?
SAS.
SAS, good. So you have a plan of attack. I need to prove SAS. Do I have any evidence to prove that yet? If I want to prove SAS, I need to prove one side is the same as the other. I need an angle is the same as the other. And I need another side. So I need at least 3 lines. So, what do I know about BC and DC? They're exactly the same. So, my first statement, Your Honor, is BC is equal to DC. Is there a reason for that, or is that literally drawn like that? So you write given. Because, so how do I write because? What dots? Where is it pointing? Downwards? Because given. Okay? In your books you could write duh, but not in your text. I need to mark it properly, okay? Given. What other sides are given? Is equal to? Because? You told me I need to prove side angles. Side. Are any of the angles marked here? No. But, according to our little toolbox here, do I have a situation here that allows me to prove? Yep. What is that?
Vertically opposite.
Vertically opposite. That's the reason. But how do I word the argument? So I've given you a symbol here, angle. So how do I name angles? I name it with the point, and then where the point is in the middle of the letters, and then the last thing there. So angle ACB is equal to, how do I say the same angle in the bottom triangle? DCE, angle DCE, because of what?
Vertically opposite.
Good. I'll just shorten that there. Have I proven the 3 things that I need to prove side angle side? What's your symbol for therefore?
Upwards.
So what you're going to say, triangle ABC. How do I say something's congruent? What symbol do I use?
The little thing that equals.
Congruent to triangle what? C. I'm doing the same order. DCE. Why? What congruence rule are you using to prove that it's true? SAS, because of SAS. We're not finished yet. That's just proving that they're congruent. So we've done this. What am I actually trying to prove? AB is parallel to? I want to prove this is parallel to that. How do I do that?
Therefore.
I like that. Therefore, do I have anything here that's got to do with parallel line? Look at these reasons. But which one would apply here? I want to prove that AB and DE are parallel. So if they went on forever, is there a line going through both of those? DE goes through both of them? Or DB goes through both of them? If I prove that this angle here is the same as that one there, then are they parallel?
Yeah.
So the opposite of this? Is that true? Why? Why is it true? Because they're congruent. Okay? So like he said, therefore, so angle CBA is equal to angle CDE because congruent triangles, and because now I've proven that those angles are the same, what rule am I using to prove that those lines are parallel?
The alternate angle.
Yeah, alternate. You've got alternate. So therefore, AB is parallel to, use the two vertical lines, DE, because of what rule? Alternate angle. That's a two-column proof. Where does the two columns come from? Is there a statement? Is there a reason? Statement, reason. Why did I need at least 3 lines? Because I needed to prove side, angle, and side. Now that I proved that they were congruent, then I could use this rule here to show that they were parallel. Okay? Can you get that example down, please? In your homework, and now it's 9A, B, C. 9A is literally telling me if shapes are the same. It's C that's going to take some work, okay?